Hello guys, welcome to Ramta Solutions. Today we are looking at vertical projectile motion. So without any waste of time, let's define some keywords that you need for this section. The first word is projectile. Alright, the first word is projectile. Now, what is a projectile? A projectile is an object. Okay, a projectile is an object that is launched and then moves only under the influence of gravity. Let me write that down. Okay, so it only moves under the influence of gravity. It's launched and only moves under the influence of gravity. The second definition that you need for this section is free fall. Okay, now free fall is a motion, while projectile is an object. So free fall is motion of a we should say it's motion of an object in which the only force acting on it is gravity. Okay, I'm gonna write that down. Let me say is gravity. Okay, so the two definitions I gave you, projectile is an object and free fall is a motion. So we said projectile is object that is a projectile rather is an object that is launched and then moves only under the influence of gravity, while free fall is motion of an object in which the only force acting on it is gravity. Now here we say that objects are falling at, okay, here objects are falling at 9.8 meters per second squared downwards. Okay, 9.8 meters per second squared downwards. Okay, this is when objects are only affected by gravity, they will be falling at 9.8 meters per second downwards. So remember, this is gravitational acceleration. Right, this is gravitational acceleration. So in this section you ignore air resistance. Okay, in this section air resistance is ignored. Okay, in this section air resistance is ignored. Okay, so why we are ignoring air resistance is this. So with air resistance, what we are saying, we basically saying we know rather that air resistance is proportional to velocity. What I mean is that the faster the object, the greater the resistance the object will experience. So we are assuming that we don't have air resistance. Now when we don't have air resistance, or when air resistance is negligible, we are ignoring it, only gravity will affect the motion of an object. Okay, so I repeat, we know that the faster the object, the greater the resistance this object will experience. In addition, this air resistance is also affected by the area of the object. So for bigger objects, bigger objects will somehow have a greater air resistance. This is where you see their velocities decreasing over some time. Okay, this is where you see velocity of an object decreasing over some time. It's because air resistance is greater. Okay, an example is when let's say a paraglider is flying. So if one spreads their arms, or what we call the wings, they wouldn't fall as fast as they would when they didn't spread their wings. Okay? All right. Now, let's look at the next thing. So, now, what if we drop two objects? What if we drop two objects? I'm going to try to see if I can find maybe spheres. I'm not sure if I can find spheres, but let me see if I can find spheres. Okay, I don't like this color. Okay, let me take gray. Okay, let's look at this sphere. I'm going to copy it and I'm going to make this one smaller. Okay, let's look at these two objects. Let's look at these two objects. Let me name this one object A, while I name this one object B. Right? While I name this one object B. So what is happening is when we talk of objects under free fall, they will all assume free fall. Let me say that. When we assume free fall, one, they will all land at the same time. Okay, they will all land at the same time. Right? They will all land at the same time. They will have the same acceleration, or they will accelerate in the same way. They will have the same acceleration. All right, and they will have the same velocity. Right? They will have the same velocity. Right? They will have the same velocity. So in our vertical projectile motion, our objects, their sizes do not matter. Right? Their sizes do not matter. Right? Their sizes do not matter. The only thing that is important is the fact that we're saying all other factors are not important. What matters here is what are their initial velocities, their final velocities. But if we assume free fall, they will land at the same time. If they were dropped at the same time, they will have the same acceleration. What is that acceleration? 9.8 meters per second downwards. Right? And they will have the same final velocity. Okay? So this is what's happening with your vertical projectile motion. Okay, now let us imagine an object launched, or launched object. Let's look at launched objects in detail. Okay, let's look at launched objects in detail. Remember, our motion here is free fall. Okay, so if object is dropped, initial velocity will be 0. Okay, if object is dropped, initial velocity will be 0. So here we're talking of maybe, I don't know, you on top of the building, you drop your object. This velocity here is 0. Okay, so this is important. Remember it. Okay, remember it. It's very important. Okay, nah, I don't like it. Remember it. Let me just do this. Okay, when an object is dropped, initial velocity is 0. Okay, now let's look at when, okay, I'll look at it in the next page. Let's look at when object is launched upwards. So launched upwards, when an object is launched upward. So here you have something like this. Let's say you were, I don't know, whoever you are. Let's say this is you and your object, and then this is your ground. Okay, so here, let's say your object was here. The initial velocity here is not 0. Right? Your initial velocity here is not 0. And then we will call this part here, maximum height. So as you can see, when you say maximum height, so you have initial velocity here. Velocity from here, it will decrease until it gets to 0 and then increase backwards. All right. So at maximum height, I'm going to call it at h max. At maximum height, velocity is 0. Okay. When an object is launched upwards, at maximum height, velocity is 0. Okay, let me order this work nicely. Okay, it's fine. Okay, first point. Second point, at maximum height, velocity is 0. Right, at maximum height, velocity is 0. So when an object is launched upwards, there is something that we call time symmetry. As you can see, this looks like a parabola. So there's something that we call time symmetry. So here we have time symmetry. Okay, when an object is launched upwards, we have time symmetry. So what we are saying is that time interval during upwards motion, so I'm going to say time interval during upwards motion equals time interval during downwards motion, but where? To return to initial position. All right, to return to initial position. All right, to return to initial position. So if this was your initial position, time taken to reach maximum height must be equal to time taken to return from maximum height to that initial position. Let's say this position is here. Okay, so basically maximum height is the axis of symmetry of this position versus time. Okay, so remember, time taken to reach maximum height is equal to time taken to return to initial position from maximum height. So as you can see, there's time symmetry here. Okay, there's time symmetry here. All right, now last point that I have to mention for these guys is that magnitude, I was using black color, is that magnitude of the velocity. So magnitude of the velocity of the upward motion, or rather on the same point, I should be saying magnitude at the same point on the upward motion and the downward motion will be equal. So what do I mean? I'm saying the magnitude, I know velocity is a vector quantity. All right, I know velocity is a vector quantity, so I am very aware of what I'm saying. I am saying magnitude. So if this velocity here, okay, I'm going to use a different color. If this velocity here is 7 meters, the ball will also return at 7 meters here, 7 meters per second. All right, it will also return at 7 meters per second. However, the directions will not be the same. The object here would be 7 meters upwards, while at this point it will be 7 meters downwards. So only their magnitudes will be equal. Okay, magnitudes will be equal. However, because they are vector quantities, one will be positive and the other will be negative, depending on the position you chose as positive. Okay, depending on the position you chose as positive. We have velocity versus time graph, acceleration versus time graph, and position versus time graph. I will drop a link in the description. Okay, so these are the things that you need to know. So let me write it down. Magnitude of velocity, so magnitude of velocity at the same point, is equal, Remember, when I say is equal, I mean for upward motion and the downwards motion. Is equal or is the same. Okay, these are the points you need to know before you do your vertical projectile motion calculations. Okay, if you can know this, you will be okay. So remember, there are graphs as well that you will be using, and we will drop some exercises as well, which we will be using to explain projectile motion in detail. Okay, great. So let's then head. Oh, by the way, you see here the object didn't return to the thrower. It passed the thrower's hand and hit the ground. So the velocity here will not be equal to the velocity here. So for effect, this velocity will be greater than this velocity here, right? Yes, it will be. It will be greater than this velocity here. But that depends on many factors. However, we know, remember what I had said? I had said velocity decreases, right? And then it gets to 0 and then it increases. Hence I said velocity, final velocity at which the object is striking the ground will be greater than the velocity here. Remember, velocity decreases, 0 increases. Alright? Okay. Now, we then use equations of motion. Right? We then use equations of motion. So in grade 10, you came across these formulas. You once said in grade 10, let me say grade 10 as a reminder, you once said VF equals VI plus A delta T. You also said VF squared equals VI squared plus 2A delta Y. And you said delta Y equals VI delta T plus half A delta T squared. Finally, you said delta Y equals VI plus VF all over 2 times delta T. So this was acceleration because this was a rectilinear motion. This was a rectilinear motion. So this was acceleration that you had to calculate or was given to you. But this was a rectilinear motion. But for grade 12, we then say we are no longer dealing with this rectilinear acceleration. Our acceleration is now equal to 9.8 meters per second squared, which we also know to be gravity. All right, which we also know to be gravity. By the way, I made a mistake here. In grade 10, you were not saying delta y, you were saying delta x. All right, you were saying delta x because you were moving in the horizontal. All right, you are moving in the horizontal. Now, because you are in grade 12, you are now moving in the vertical. So you say VF equals VI, of course, plus, I'm going to write A, even if you write G, it's okay, delta T. And you will say VF squared equals VI squared plus 2A. We no longer move on the horizontal, we move on the vertical. So it will be delta Y. Again, delta Y equals VI delta T plus half A delta T squared. Finally, delta Y equals VI plus VF all over 2 times delta T. So as you can see, the equations are the same, just that in grade 12, you are saying you are now moving along the vertical axis, right? You are now moving along the vertical axis, hence you are using delta Y instead of delta X. And a reminder, your acceleration is now equal to gravity. Remember, gravity is always moving down, right? It's always moving down. And these are vector calculations. which we will cover in the next video. In the next video, we will be doing examples or exercises where we will be making sense of this, okay? Where we will be making sense of all these things that we were doing, okay? We will be making sense of all these things that we were doing, okay, guys? With that being said, it's a wrap. See you next time. Bye bye.